Hi guys. So we have this question on the vectors. Let's see how we can break it down. The question reads, vector A has magnitude 3 units and lies along the negative x-axis. Vector B, we're supposed to have a vector B somewhere there. So vector B has a magnitude of 6 units and makes an angle of 30 degrees with the positive x-axis. So find the scalar product AB without using the concept of components. So how can we find the scalar product A dot B without components? So to start with, just so to understand this, let's put it here. We have to draw some form of a rough diagram. So look like this. And on this diagram, we shall put the two vectors. According to how the question has been broken down, we can say that vector A, which is along the negative x, so vector A will be somewhere here. This is my vector A. Look at this. So this is vector A. Then vector B makes an angle of 30 degrees with the positive x-axis. So since angles will be measured with respect to the positive x-axis in the anticlockwise direction, then this here is 30. Like this. So this is our vector B, and this is our vector A. Okay. So we know that going up there, that's a positive y. In this direction, this is a positive x. In this direction, this is the negative x, and down there, this is the negative y. Okay. So we have the vectors that we're looking for, A and B, represented on the diagram. So now, how can we find the dot product? So the formula to find the dot product is given by cos theta is equals to A dot B over the magnitude of A and B, like that. So what happens now here is, since I'm looking for A dot B, if I cross multiply, I'll have A dot B is equals to the magnitude of A times the magnitude of B multiplied by cos theta. Now, it's important to note that theta in this case is not representing direction, but rather it's representing the angle between the two vectors being A and B. So what is the angle between the two vectors? Since the straight line is 180 and we have a 30 here, if we say 180 minus this 30, we are going to get the angle between these two vectors. So this angle here, this is our theta. So 180 minus 30, then the angle between the two vectors is 150. So A dot B is equals to the magnitude of A. Remember, A has a magnitude of 3 units, so 3. The magnitude of B, B has a magnitude of 6, cos 150. So A dot B is equals to 18 cos 150. So if we compute this, we'll find that A dot B is negative 15.6. So that's the dot product that we find without using components. Now for the second part, it says using components. We are supposed to obtain the same answer, but in the process of obtaining the same answer, we should use a different concept, and that concept is under components, of course. So let's see now how we can use components to obtain the same solution. So to start with, part B. From the diagram that I have here, for A, we're going to look at the components for A, the components for B. So the best thing we can do is components for A, I will say AX. X is given by A cos theta. And the component for Y will be given by A sine theta, like that. So AX, now what is A? The magnitude of A, remember, is 3. So 3 cos. Now this theta is representing the direction for the vector. So the direction for vector A is 180. So AX, we have 3 cos 180. So 3 cos 180 is simply negative 3 units. For this other one, we have A sub y, which is equals to 3 sine the direction for vector A, 180. So this will give us 3 sine 180 is simply 0 units. Like that. Okay, so from there now, let's find the components of vector B. So if I go back to my diagram, this is what will happen. I'll draw an x component for vector B and a y component for vector B. So what I've created is a right-angled triangle like this. So since the y here is opposite, remember this is by, down here we have b, this is bx. So the y is opposite, so I'll use sine. The x is adjacent, so I'll use cos, according to Sogaton. So how do we find what we're looking for? We'll say, same thing, same procedure, bx. Bx is found by b cos theta. By is found by b sine theta. B is the magnitude of b, theta is the direction. So bx will be equals to, what is b? Magnitude of b, we said is 6. So 6 cos, what's the angle? 30. That's the direction for this vector. By will be 6 sine 30, like that. So if we compute this, bx is equals to negative, not negative, sorry, it's a positive 5.2 units, while by is simply positive 3 units. Okay, so we have the components. Remember, part B was supposed to use components. So this is the x component for A. This is the y component for A. This is the x component for B. And this is the y component for B. So how can we find the scalar product for these two vectors? Remember, we're now using the concept of components. For the first part, we found this answer without using any part of components. So for this one, this is what I'm going to do. Let's write them as unit vectors. So vector A can be written as the x component is negative 3, so let's say I. The y component is 0, j. So using these two components, we can write vector A like that. Using these two components, let's rewrite vector B. So meaning that vector B will become 5.2i plus 3j. So we have vector A and vector B. Now let's proceed and find the dot product. So the dot product, which is A dot B, will be given by vector A is negative 3i plus 0j dot vector B, which is 5.2i plus 3j. So A dot B, negative 3i times 5.2 positive. Remember, the I and the I will just give us 1. So negative 3 times 5.2 will get negative 15.6. 0 times 3 is 0. Remember, j and j is 1, I and I is 1. So A dot B is negative 15.6. So you can see that the two answers are the same. So since the two answers are the same, we have used the two concepts. For the first one, we have used, or we haven't used the concept of components. We just looked at the angle between them. While for the second one, we have used the concept of components. So I hope it makes sense. Thank you very much. In case you have a question, please feel free to drop it in the comments. Have a good day.